morning children, welcome back to your periodic table chapter. So we had come to modern periodic table, right? So modern periodic table, it is also called as long form of periodic table. And who had proposed this modern periodic table? In 1913, Moseley had proposed this modern periodic table. He showed it by X-ray analysis that atomic number was more fundamental property of an element than atomic weight and gave this modern periodic table. Okay, so how can we define what is modern periodic law? This I had also given you in my last video. So modern periodic law states what? That physical and chemical properties of the elements are the periodic function of their atomic numbers, right? So this modern periodic table was prepared by Niels Bohr, okay, and therefore it is also known as long form of periodic table, and it is completely based on modern periodic law. Now let us describe about the modern periodic table. Let us learn some more points about modern periodic table. So first point about it, that this table is based completely, as I told you, on modern periodic law, right? The elements, they are arranged in increasing atomic numbers such that these elements, they have similar properties that occur in the vertical column, that is called as a group, right? In this table, the vertical columns, what are they termed as? Groups. So I'll write over here, vertical columns called as groups, okay, and horizontal rows were called as periods. Fine. Then second point, elements arranged in increasing atomic number, right? Then over here, look at the groups. Let us talk about group first. Period I am going to talk about little later. Let me talk about the groups. So look at the groups. The groups are 1A, 2A, then 3B, then 4B. Check the periodic table that is shown over here. Then 5B, then 6B, 7B, eighth one, it has no AB, okay? Eighth is a complete group. Then we have 1B, then we have 2B, then 3A, then 4A, 5A, 6A, 7A, and the 0 group. Okay, these are the groups. So you can see over here, these groups have been divided into two subparts. What are they? Group A and Group B. Okay, so now we are going to discuss about some more important points in the groups. So according to the latest IUPAC name, these names in the Roman numbers, they have been numbered now. How? 1 to 18. Okay, and let us now talk about these groups. So group 1, look at group 1, it is called as an alkali metal. Okay, group 1 is called as alkali metal. Why are they called alkali metals? Because they form strong alkalis. They form strong alkalis. Now what are alkalis? When the metallic oxides, they dissolve in water, right? They form strong alkalis. Group 2, Group 2 are called as alkaline earth metal. Alkaline earth metal. Now what is alkaline earth metal? They also form alkalis, right? They also form bases that are present in the earth's crust, but they are not strong alkalis. They form weak alkalis. Then we come to group 17. Group 17, look there, group 17, they are called as halogen family. Okay, halogen family, why? Because they are salt formers, therefore they are termed as halogen family. Salt formers. Fine. Then let's talk about group 18. What do you see in group 18? They are all noble gases. Right? What are noble gases? They are inert gases, they are rare gases which do not react with any other elements, right? So they are rare gases. Now the elements of groups 1, 2, 13, 14, 15, 16 and 17, they are the main group elements, or they are also termed as normal elements, right? Or we can also call them as representative elements or typical elements, right? Now, so groups 1, 2, 13, 14, 15, 16, 17. What are they termed as? They are termed as representative elements. Okay. Now if you see the representative elements, or they are also called as typical elements, the outermost shell is incomplete. Okay. Typical elements and the outermost shell are incomplete. Okay. Then we come to groups like 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What are they termed as? They are called as transition elements. Okay, their two outermost shells are incomplete. In transition elements, what do we say? That two outermost shells are incomplete. Okay, then now we come to periods. I hope everything about groups are very clear to you. Now we talk about periods. Okay, so what did I tell you about periods? They are the horizontal rows. How many horizontal rows? 7 horizontal rows. 7 horizontal rows are termed as periods. So let's see the first period. The first period, if you check the periodic table, first period, it has just 2 elements. What are those 2 elements that you can see over there? Hydrogen and helium, right? With atomic numbers 1 and 2. So this is termed as the shortest period. This is the shortest period. Okay. Then we come to second period. Second period, it has 8 elements. And this is called as a short period. This is called as a short period. Okay. The elements and the elements that are present over here, they are known as bridge elements. Okay. Then we come to the third period. Third period, again it has 8 elements having numbers, if you check the periodic table, 11 to 18. So this is also your short period. This is also your short period. Okay, and they are elements known as typical or representative elements also, right? Then let's come to the fourth period. Fourth period, it has 18 elements. It has 18 elements, right? And its atomic number ranges from 19 to 36, and this is called as your long period. This is your long period. Then the fifth period. The fifth period, it has 18 elements again, and these 18 elements, they are again they are also called as the long period. right? Now look at the sixth period. Sixth period, it is the longest period. Why is it the longest period? Because it has 32 elements present over here. It has how many? 32 elements present here. Therefore, this is called as the longest period. Fine. And we come to the seventh period now. The seventh period, it is an incomplete period. Why? Because it has 31 elements with atomic numbers 87 and onwards. Means still more elements can be accommodated here. So it is an incomplete period. So I hope everything about period is clear to you. Now let us look down in your periodic table. You have lanthanide and actinide series. Lanthanide and your actinide series. Okay, now lanthanide series. The atomic number, it ranges from where? 58 to 71. That is in the sixth period, group 3. From where do we pick up this lanthanide series? It is sixth period and group number is 3. Group 3. Okay, these are called as lanthanide series. And where do we get the actinide series from? It ranges from 90 to 103. And you will see that you pick up this actinide series from where? Seventh period, group 3. Okay. Now the first element that is present in the lanthanide series is your lanthanium. The first element in the actinide series is actinium. Now what are lanthanide series elements called as and what are actinide series element called as? The lanthanide series, they are termed as rare earth metals. Rare earth metals. Okay. And your actinide series, they are radioactive metals. Radioactive metals. So you can check the radioactive metals, like you will find uranium, thorium, all these things you are going to find in the actinide series. And together, what is this? They are termed as inner transition elements. Why are they called as inner transition elements? Because they are picked up from the transition set of elements. So therefore they are termed as inner transition elements. I hope this is very clear to you. Now let us talk about, on the basis of the electronic configuration of the elements, this complete periodic table, it is divided into 4 blocks. What are those 4 blocks? They are S block, P block, D block and F block. S block, P block, D block and F block elements. Okay. Now look at the S block elements. So over here, group 1 and 2, they are your S block elements. Check in your periodic table. Then P block elements, these are group 13 to group 18, they are P block elements. Then talking about D block elements, they are group 2 and 13, right? Between group 2 and 13, let me write down to group 2 to 13, they are D block elements, right? And then F block elements, what are F block elements? The lanthanide or actinide series or your inner transition elements, they are termed as F block elements. Okay, they are found in F block. So they are inner transition elements. So I hope all the important points about modern periodic table is clear to you. Now let us talk about some advantages and disadvantages of modern periodic table. Okay. So firstly, coming to advantages, simplified chart, easy to remember. isn't it so? Then another point could be it is completely based on atomic number, right, which is the most fundamental property of an atom. Then it relates the position of an element to its electronic configuration, right? It also explains the variations and similarities, right, in the properties of the elements, in the properties of elements. Clear? Then the noble gases, they have been assigned a proper position in the periodic table. They do not hinder with other elements. They have been placed absolutely separately. Noble gases have been placed separately, right? Then what else? It also explains the trend in the properties of elements more properly. Explains the trends in properties of elements more properly. Then it clearly demarcates the position of your metals, non-metals, metalloids, your inert gases, your transition elements, lanthanide and actinide series. So completely it gives us a good, easy and simplified study of all the elements. Okay. Now talking about the demerits or the disadvantages. What are the disadvantages of modern periodic table? Not much. Handful of them. That is maybe the position of the hydrogen. Right? It is yet not certain in the periodic table. Then what do we know about lanthanide and actinide series? Since they were not being able to accommodate in the main body of the periodic table, so they have been brought down. So in fact I feel bringing them down, it has given a good look to the periodic table. Had it been placed there only in group 3, then it could have distorted the shape of the periodic table, isn't it? Then few elements, they are not arranged according to the configuration, and this rearrangement does not much affect the periodic table as well, because they do not reflect the electronic configuration of many transition elements and even the inner transition elements, right? So with this we stop over here. So disadvantages are not much. Mainly you can learn 2 or 3 of them. As I said, that the position of hydrogen is not certain. Then the lanthanide and actinide series, they do not find a proper position in the periodic table. Few elements, they are not arranged according to the electronic configuration, and this arrangement also does not reflect the electronic configuration of many transition elements and the inner transition elements. So that's it for today. Thank you.